Now is the question time. Would we be able to check if the water is hard by using detergent? No, because the detergent behaves exactly same with hard and soft water. So there is no way to differentiate. People use a variety of method to wash clothes. Usually after adding soap, they beat the cloth on the stone or beat with scrub or brush. Right? We use brush or stone, right? Brush to scrub. Why? Why is agitation necessary? This is necessary because, as I told, right, the soap, those are soap form mistles. So mistles have this dust, right? That is the dust. It will form this mistles like this. It will form mistles like this. So mistles, in this mistles, my dust is trapped, right? My dust is trapped. My dust is trapped, but this mistle itself is trapped inside the cloth. So to kick this out, to kick the mistle out of the cloth, we use this guy, brush or stone, because this mistle is suspended as colloid in water inside the clothes, right? To remove this mistles, to remove mistles, we use brush or stones or something like this. While cooking, if the bottom of the vessel is getting blackened from outside, it means that one of these, which one? Food is not getting properly cooked. No, wrong. Food is not burning properly. Yes. So if you're getting yellow shooty flame and smoke, that means the fuel is not getting burned completely, right? So in that case, you do something. Maybe the air hole is less. Something happened. So you have to fix that issue. Explain the nature of covalent bond using the formation of CH3Cl. So we have carbon, we have 3 hydrogen, we have 1 chlorine. Chlorine has 7, 1, 2, 3, 4, 5, 6 and 7. Carbon has 4, 1, 2, 3, 4. Hydrogen has 1 each. So I'll form a bond between carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, and one guy with this. So with this, if you see, chlorine is assuming that it has 8. Hydrogen assuming it has 2, hydrogen assuming it has 2, this guy also assuming it is 2, and by this carbon, assume that this guy has 8. This is how the covalent bond is formed, right? So carbon assumes it has 8 because 4 it has its own, and 4 it has got 1 each from 3 hydrogen and 1 chlorine. Correct? And chlorine had 7, it wanted 1, so it shared 1 with carbon, so it assumed that it felt that it has 8. And similarly with hydrogen, it felt that it has 2. Let's draw the structure of ethanoic acid, H2S, propanone, and F2. All these. So ethanoic acid we know is nothing but CH3COH. So let's draw this. C, my hydrogen, 3 hydrogens. C, O is here, right? The formula is like this, COH, O comes here. Now, let's draw this. Carbon has 4. Carbon has 4. Oxygen has 6. Hydrogen has 1. So this guy forms a bond with this. So this, it has got 7. We'll bond the next guy with bond with carbon. So it has got 8 now. This carbon has got 4. It has formed 1 bond with another carbon, another 5. It will form 2 bonds with oxygen. 7 and 1 bond with oxygen. 8. This oxygen had got 6. Form 1 bond with carbon. 7. 1 bond it will form with hydrogen. So this is the formula of ethanoic acid. Next is H2S. So I have 1 sulfur, 2 hydrogen, right? Sulfur has 6. Hydrogen is 1 each. This guy will share like this. Sulfur will assume it has got 8. Hydrogen will assume it has got 1. Then I have propanone. Propanone is like this. CH3, COO, CH3. Correct? This is the propanone thing. With it top, 3 carbon. So let's form the structure of this. 3 carbon, oxygen, and then hydrogens. 1, 2, 3 here. 1, 2, 3 here. Hydrogen has 1 each. Let's draw. Carbon has 4 each. right? Sorry, let's draw here only. So let's add CH, and this oxygen will form double bond with this guy. So it had 6, oxygen had 6, it formed double bond with this guy. Oxygen had a form covalent bond with carbon, it got 8, 2 from sharing. Similarly, this carbon had 4, it got 3 from hydrogens, 4 plus 3 7, and got 1 from this carbon, 8. This guy also had 4, it got 2 from this oxygen, 6, 1 from this carbon, 8. This guy got 3 from this hydrogens and 1 from this carbon. You got this. Similarly, F2, fluorine has 7, 1, 2, 3, 4, 5, 6, 7. Let me draw this one, 1, 2, 3, 4, 5, 6, 7. So they need to share one atom. So if they share one atom, this guy feels that the guy got 8 because of 7 it has, 1 it got from sharing, and this guy had 7, 1 it got from sharing. How can ethanol and ethanoic acid be differentiated based on the physical property? So, as I told that ethanol is sweet smell, because I'm talking about the physical property, right? Ethanoic acid has a vinegar kind of smell, the strong smell, right? Both are liquid at room temperature, but this guy, ethanoic acid has a low melting point, 70 degrees Celsius. So in winter also you'll find that this guy is a solid in winter, right? Because it has low melting point. So it is 10 degrees Celsius to become solid, but this guy will be a liquid in winter. So if it is winter, you can just tell by looking at the thing. If it is liquid, it is ethanol. If it is solid kind, it is ethanoic acid. Or by smell, you can take that ethanol has sweet smell and ethanoic acid has a vinegar kind of smell. Why does the micelle formation take place when soap is added in water? Well, the micelle will form when any other solvent is used. It is no, it won't be formed when you use any other solvent, right? Why? Because ethanol is not polar. Ethanol is not polar. As I told, the way micelle is formed, that the soap has this Na plus thing, and then it has a long carboxylic acid, right? And the way it works is, if it has got dust here, this is my dust, then all this soap is formed like this, interact like this. You have sodium ion here and this long chain of carboxylic acid like this, right? It forms a micelle. It forms a spherical kind of thing. It traps this dust, correct? It traps this dust like this. I have this like this. Okay. This is how it is formed, right? It's a lot more actually. You got this micelle, and this is formed when you have a water kind of molecule, because this guy is nothing but it needs some polar solvent to work, right? Because as I told, the way we are using soap is because we have this dirt which is oily and which is insoluble in water, and we have water, right? We have to make them soluble, then we're using soap. So soap has this part, Na part, that is soluble in water, and this part, carboxylic chain, that is soluble in oily acid, right? So if the water is not there, it won't work. So, to explain the formation of scum when hot water is used with soap, as I told, soap is what? Soap is nothing but sodium or potassium salt of long chain of carboxylic acid, fatty acid, right? Anything. My hard water is what? Hot water has what? Has calcium, manganese. Now, if I use these two, if I add these, this calcium and manganese may replace potassium and calcium. It may form calcium and magnesium salt of long chain of carboxylic acid. This guy is called scum. Correct. And this guy is insoluble in water, and this guy is a white precipitant thing which makes things more bad. It sticks to the clothes. So the logic is if this calcium and magnesium ion displace this sodium and potassium and it forms calm. What will you observe is you test soap with litmus. Soap, as I told, is basic, and basic is the red will turn blue, and if you have blue litmus paper, it will still be blue, right? So since soap is basic, so soap will turn red to blue, and if you put blue litmus paper to soap, it will still be blue. What is hydrogenation? What is the industrial application? Hydrogenation is nothing but process of adding hydrogen to something. So you have unsaturated hydrocarbon. So you add this on nickel, presence of nickel catalyst, right? You add hydrogen in this, so it becomes saturated. This process is called hydrogenation. And in industry, we have this vegetable oil, which is converted to dalda or ghee using hydrogenation.